Alright, let's start with this question. We're given a truth table here, and we're supposed to state the type of logic gate. So let's go through them. The first input is 0, second input is 0, and then the output is 1. So it's not an AND gate, because for an AND gate to get a 1 you need 2 1s, so it's not an AND gate. It's not an OR gate either, because an OR gate cannot give you a 1 with 2 zeros. It's not a NOT gate either, because a NOT gate has only one input. So let's try a NAND, not an AND. 0 0 1, that's fine for a NAND. This is second row is also fine, third row is fine, and the fourth row is also fine. So this is a NAND gate. This is the opposite of an AND gate. Alright, so the second question now. Complete the truth table for the following logic circuit. So let's just name our gates here. This is an OR, this is an AND, this is a NOT. Alright, we can easily do D for the NOT gate. So whatever B is, D is not. So whatever B is, D is not. B is 1, so D is 0. B is 0, so that's 1. Good. Now we can E is an AND gate. And the only way we can get a 1 for an AND gate is if we have two 1s. So C and D are connected to E. So since D is 0 here, we know that is 0. This is 0 here. So this must be 0. So the only 1 we can get is if this is 1. If this one here is also a 1. So that's the only way we can get a 1 over here. For this pin here, it is linked to B. So whatever B is, that pin is the same one. That connection is the same thing now. So B is 1, so that means that one up there is 1. A is 0. And B is 1, so C is 1. A is 1, so it's an OR gate, so that works. This also works for an OR gate. And C and D are 1, so that's 1. And that's 8 marks. Okay, so draw, clear, and identify the circuit symbol in the logic gate. So on NOR gate, that's not an OR. NOT gate is triangle, circle at the top. NAND gate, like a popsicle, 0 at the top, and it goes on. And OR gate, there you go. Alright, so we're supposed to complete the truth tables 3 and 4. Alright, so not an OR. So what is not an OR? So in an OR gate, 0 and 1 will give us 1. 1 and 1 will give us 1. So that's 0. That's 0. Because we're not an OR. 0 and 0 will give us 1. AND gate. The only way we get an output of 1 in an AND gate if we have both inputs as 1. So that's 1. That's 0. That's 0. That's 0. Alright, so the logic circuit is shown in figure 3 can be used to warn a driver that he is about to leave the car with the headlights switched on. Table 5 represents the truth table for the logic circuit. Complete table 5. Alright, so we have headlamp switch, ignition switch, driver switch. So let's check out our logic gates now. We have two AND gates and a NOT gate. Alright, simple enough. Let's do the NOT gate first, which is the ignition switch, which goes to X. So the input is IS, goes to X, and it's a NOT gate. So whatever the input ignition switch is, the out X is NOT. So we have 0, so that turns to 1, 0 that turns to 1, 1 turns to 0, 0, 1, 1, 0, 0. So we're using the input switch to get this result. Whatever this is, the ignition switch is, this is not. Next one we can do now, let us figure out Y. Y is an AND gate. So because it's an AND gate, both inputs must be 1 for it to work. So anywhere we see a 0, we can automatically put a 0 without consulting anything because it's an AND gate. Now, because it's an AND gate, we need a headlamp switch, this one here, to be 1, and we need this to be 1 for the output Y to be 1. So since the first one is 0, we know that is 0. We have a 0 again. This one is a 1. This one is a 1, so this is 1. 1 here again, 1 here again, so that's a 1. Now Z is an AND gate also. So if the door switch and the Y switch is 1, then we get a 1. So anywhere we see a 0, we can automatically put a 0. So 0 here, 0 here, 0 here, 0 here. We have a 1 here, but the door switch is not a 1, so that's still a 0. We have a 1 for Y, 1 for the door switch, so this is a 1. Let me change the color of that one. 1. Okay, so we have a 0 for Y again, so that's out, and that's out again. So that's 6 marks. Now, examine the results Z in column and write out in words the condition in which the alarm will sound. Okay. So the alarm will sound if, first of all, headlight switch must be on, ignition switch off, door switch on, then the alarm will go off. So those are conditions. Headlight must be on, the ignition is off, and the door is open. And that's it for logic gates.